Okay, we're looking at the second in the sketching exponential functions video, and so far, hopefully, you've got a good understanding of these ones, the straightforward ones. So we've got the first one, which is just a to the x, y equals a to the x, and y equals a to the minus x, hopefully you should know, is that one. So this is a growth model, this is a decay model. Okay, and the other one that you hopefully have understood is the one with the translation with the number up. So translation just means a movement up or down or sideways, and this one is an up and down. So this one's like having a new floor, I call it. Y equals b, and then the graph just still goes up. If it's just plain old a to the x and it always has a y-intercept of 1, this is the new floor, so this new value here would be b plus 1, for instance. And also don't forget that the base a can't be a negative number. So you can't have bases that are negatives. You can have fractions. Okay, that's okay. You can have decimals. That's okay, but you can't have a negative base. Okay, so you've done that, so come across when you're ready. So what we're going to look at are variations where we have a coefficient in front and a number in the power. And ultimately, you know, you could be modeling something in science or whatever that might have all the different changes all put together. So we're going to be looking at these two in the next slide. So come across when you're ready. Okay, so what we've basically got is a dilation or a stretch factor of that value b. So for instance, we have 3 times 2 to the x. Our normal 2 to the x is a quarter, a half, 1, 2, 4, 8, and then 3 times that is just 3 quarters, 3 halves, 3, 6, 12, 24. And so we're going up. We'll go up in fives. So 25, 1, 2, 3, 4, 5, 10, 15, 20. So 3 quarters. Again, like it's pretty dodge, but down there, minus 1 is 1.5. So it's down there, and then 3, and then sorry, 0 is 3, 1 is 6, 2 is 12, and 3 is 24. So you still get the same shape. Okay, don't forget it asymptotes. Don't forget down this end, make sure your curve comes down. It doesn't sort of move away. That's bad. Okay, so this is a dilation, like a stretch. We're not moving the curve sideways. We're just sort of stretching it. Okay. Now, whether you do a separate table and then do a new table, if you're doing a table of values, that's up to you. Or we can just go straight to the the second answer. Okay, copy and come across when you're ready. Come on. Okay, so now we've got a new value with a power. Okay, and this is going to be a sideways translation. So basically, when we take this number, say for instance 3, 2 to the 3 minus 3 equals 0. So when you have 2 to the x minus 3, when you have 3 minus 3, so basically where we used to have 1 at x equals 0, now we've got it over here. So what we're doing is basically we're moving the curve in the opposite direction. So basically minus 3, x minus 3, means the curve has been pushed to the right 3 spots. Okay? So where we used to have 2 to the 0 is 1, now we've got 2 to the 3 is the 1 value. And so if you do your table of values, it's going to be small numbers, that's definitely. So let's go back to the normal. Let's just go back to 2 to the x. So that's going to be 8. To start from here. 1, so a quarter, a half, 2, 4. Yeah, you don't have to do it this way, but I'll do it this way. So y 2x minus 3. So this number here has come across. So that's going to be a half, a quarter, an 8. So this is a bit ridiculous, but so we've got this value minus 2, minus 2 minus 3 is minus 5. So this value is the 2 to the minus 5. So this is when it's going to start taking off, and all these values back here are asymptoting. That value there, 2 to the 0, 2 to the 0 is, so that value there is 1/8. So that's where basically you've moved the y-axis to a new y-axis there. Like, it's not the y-axis, but you've moved the y-axis sideways 3 spots. Okay, come across and see what we've got next. Okay, so what I want you to do is try this by yourself without a table of values, just by looking at what translations we're doing. I'm not putting a dilation factor out the front. We're just going to move it sideways and up and down, and have a go yourself. Okay, let's have a look. So we've got 2, 3. So this 3 is your new floor. So where we used to asymptote at the x-axis, now we're going to asymptote there. This +1 means the y-axis is moving backwards to -1. So there's your x and y axis, sort of, so to speak. And so basically, just to get this y-intercept, 2 to the 0 is 0 plus 1 is 1. 2 to the 1 is 2. 2 plus 3 is 5. So it's going to shoot up and be asymptoting this way. Okay, so it's a little bit dodgy, but basically we've got a new floor and we've got a new y-axis. Make sure you got the y-intercept right, and everything else is just a sketch. Asymptoting and then going up through there. Okay, that's it. Bye.